Hi, Keenan. I just wanted to talk to you briefly about your assignment, especially number 2, and make sure that the understanding is cleared up a little bit. Um, for discontinuities in the graph, like they have in the graph for question 2, if we look at the part of the graph where x is equal to 1, we have a discontinuity, and that one's called a jump discontinuity. Probably for obvious reasons. It jumps from one value to the other, and there's a big gap in between the graph there. So when we look at question E, and it's asking for the limit as x approaches 1 from the left, and you should have from the left included there, then the value of the limit as you're approaching from the left means that you follow the curve from left to right up to the point where x equals 1. So the actual limit there is negative 3. And so it's not 2, it should be negative 3. So for part F, it's asking for the limit as x approaches 1 from the right. And if you look at that one, it is x equals 2. So what we have here is a case where at a particular value, like x equals 1, we have a different right and left limit. In other words, there are two different values for y when x equals 1, depending on if you're coming at the value from the left on the pink part of the graph, or if you're coming at the value from the right on the green part of the graph. And so we have two different limiting values there. Whenever we have two different limiting values, if we jump over to part G here, then the limiting value does not exist, because obviously if there's two different values, then it can't have any one particular value at that x value. And so we say DNU does not exist whenever the right and the left limits don't agree. So if you were doing the same thing for K, where it's asking you for, for part I, the limit as you're approaching x from, as x approaches 4 from the left is minus 1. The limit, though, as you're approaching 4 from the right is 0, not minus 1. So again, we have two different limiting values for the same x value, and that's not allowed, and so we have to say for k that the limit, again, does not exist when those two values don't agree, okay? And so then when it asks you for the limit at 4, we can see from the graph that there's no one value at x equals 4 that satisfies this equation. There's more than one, which means that this value does not exist. There is no limiting value at 4, and the function itself doesn't, actually the function itself has one value at 4. F of 4 exactly is 0, because it's a solid circle. And if you look at the minus 1 value for 4 on the green part of the graph, it's an empty circle, which means it doesn't actually hit that value. So f of 4, the function at 4 actually has a value at 0, but the limit of the function as x approaches 4 does not exist, because we have two different values coming from the left and the right. So I hope that helps understand, I hope it helps you understand this concept. Again, if you take a first year calculus course in university, then you're going to come across this idea of the limit again. It's one of the first things that you're going to hit in the first year calculus course. And I know a lot of students have a lot of difficulty understanding it, so if you take a little bit of time to really digest this and make sure that you got it before you hit university, it's going to be a big help to you next year.